Good morning and welcome back to Idaho News.
Today we'll be talking about our latest story on the scientist who discovered the double helix, James Dewey Watson. He was born April 26, 1928 in Chicago, Illinois.
As a kid, he was extremely smart and had many hobbies, such as bird watching, which he did with his dad.
Because of his intelligence, after high school, he received a tuition scholarship to the University of Chicago.
While going to Chicago because of his love for bird watching, it inspired him to major in zoology. He received a BSc degree in zoology, which then matured into a serious desire to learn about genetics.
He graduated from Chicago University, and after a few years, he was then granted a fellowship for the graduate study in zoology at Indiana University in Bloomington.
While he was there, he received his PhD degree in zoology in 1950. Watson was also deeply influenced by geneticists H.J. Muller, T.M. Sonborn, and by S.E. Lurea. Lurea was an Italian-born microbiologist then on the staff of Indiana's bacteriologist department.
Watson's PhD thesis, done under Lurea's able guidance, was a study of the effect of hard X-rays on bacteriophage multiplication.
September 1950 to September 1951, he spent his first postdoctoral year in Copenhagen as a Merrick Fellow of the National Research Council. James Watson then worked with bacterial viruses, attempting to study the fate of DNA of infecting virus particles.
Watson went to the zoological station at Naples with Merrick Calker. This stimulated him to change the direction of research toward the structural chemistry of nucleic acids and proteins. Lurea made this possible when, in early August 1951, she arranged with John Kendrew for James Watson to work at the Cavendish Laboratory, and he started work in early October 1951.
James Watson met Francis Crick, and they discovered their common interest in solving the DNA structure.
Their first serious effort, in late fall of 1951, was unsatisfactory.
Their second effort, based upon more experimental evidence and better appreciation of the nucleic acid literature, resulted early in March 1953 in the proposal of the complementary double helical configuration.
After failed attempts of model building, including their own ill-failed three-stranded version, and one in which the bases were paired with the same nitrogen bases, they achieved their breakthrough.
In April 1953, they published their findings in the journal Nature, leading to presentation of the Nobel Prize in 1962.
James Watson's discovery started the beginning of multiple other discoveries.
Watson and Crick's discovery yielded groundbreaking insights into the genetic code and protein synthesis.
Their discovery also helped to produce new and powerful scientific techniques, specifically recombinant DNA research, genetic engineering, rapid gene sequencing, and monoclonal antibodies, techniques on which today's multi-billion-dollar biotechnology industry is founded.
Crick and Watson recognized at an early stage in their careers that gaining a detailed knowledge of the three-dimensional configuration of the gene was a central problem in molecular biology. Without such knowledge, heredity and reproduction could not be understood.
I think it's safe to say that the double helix reshaped biology.